Hey everyone, this is your weekly episode of the Zephyr Podcast. I'm Benjamin, your host.
And I am Fabio, your other host. So we tagged RC1. Well, the release team tagged the RC1s. Last week was a bit of a list of boards and features while everybody was trying to get all of their last things in before the release. Looks like this time is going to be a bit of a different episode, right? We don't have as many commit. We have a bunch of industry news, though. How are you doing, Benjamin?
Great, good. Yeah, it was pretty crazy actually this week, all the things that happened. Started the week with some bad news and I'm not sure this has been sort of like publicized and really shared with the community at large, but we had applied for a dev room at FOSDEM, and that big conference in Brussels
Brussels.
every year. Like, I mean, everybody knows FOSDEM, and we've been trying for a couple of years to get in and have our own track. We tried to have a Zephyr dev room in the past. This year, we tried to have a general RTOS dev room. Got declined, so we will have to stick with. I mean, fingers crossed, we will have a stand, a table where the community can hang out. And in any case, the call for papers for all the dev rooms that got accepted. There's actually an embedded dev room. There's like security and RISC-V and video and gaming, I think even.
Oh,
So
wow.
yes, gaming actually.
Open source gaming?
Well, yeah, I mean, there's a few folks in the community, right, who work on some like crazy 3D rendering engines for like small, tiny monochrome displays and so on. People like like Vindragon and so on. Like they are.
No way.
I'm really looking forward to see what they will be submitting. So
Oh, this is brilliant. So both of us are gonna be at FOSDEM. FOSDEM is, as you mentioned, in Brussels, 31st of January and 1st of February. So book your flights, book your hotels. See you there.
you already did, right?
Yeah, yeah, yeah. I always do it well on time. I've been going for a very long time.
But yeah, so that's yeah. There's that. I mean, I'm pretty confident that we will see lots of Zephyr. Anyways, we don't need the dev room. It would be nice to have, but
Yeah,
to have it. But yeah,
I think that the key for getting a dev room is that we need to have a presence, constantly make some noise, see that the project is there, and yeah, a bit disappointing that we didn't get the room. I think that what you did was the right move, which was to ask for a RTOS room because it's very busy. There's a lot of projects, and going for a Zephyr room would have been excessive. But RTOS teaming up with folks from other open source RTOSes would be the right thing. Maybe next year.
yep. Well, I mean, there's only so much they can fit on the campus, I guess. Like they had
Okay.
140 submissions or something. So, but yeah, we'll keep trying for sure. And then yeah, we like you mentioned, we are past. We're now we have entered the feature freeze for the release, which is now going to be in exactly 2 weeks from today. So a couple more release candidates will be coming out. And I'm yeah, as every as I do every time for the past many releases now, starting to work and think about a cool demo for some of the nice features that we have. There's really quite a few, many around, like generally speaking, I guess, developer experience. Like we have an instrumentation subsystem and many tools that help with like helping people troubleshoot device tree errors, kconfig errors, yeah, a bunch of things. I mean, I don't want to spoil necessarily all the cool stuff that you will see in the demo, but one thing that I'm actually really excited about is support for OCPP, the Open Charge. I always forget one of
Point.
Open Charge Point protocol. So that is a standard. I don't remember whether it's ISO or any or something else, but essentially the standard for the communication between the an EV electric vehicle charging station and a cloud like a server basically. So that is supported in Zephyr now, which means that one can effectively build an open source Zephyr powered charging station, which is exactly what I'm going to try to do for this demo. And there's quite a few um, yeah, I think this will be nice to try and stick to the same demo scenario and show all the cool stuff that we have added. Again, don't want to spoil all the fun, but things like the Twister display harness, I'm super excited about. the ability to have Twister automatically test that graphical user interface that you put together looks like it should, and like in CI, have like a camera pointed at your display and be like, yep, sure, yes, the colors look good, the GUI widgets are in the right place, and so like do all that automated testing and a few other cool things. Again, don't want to spoil the fun, but that's been keeping me busy. I feel like I'm doing it slightly less minute than I typically do, but I will see.
So you're preparing a super demo.
Yeah, a meta or mega demo, however you want to call it. And as always, if you're listening to the episode, either like in the comments or on Discord, if you have ideas, feedback on the way things were done in the past, things you would like to see less of, more of in those demos and in the blog posts, etc., that I typically put together, please let me know because like now is the time. So.
So if you need a demo project, let Benjamin know, and he will do it for you. No, wait, that's
Sad
how it
for you to
works.
put it. Yes.
So, so how is your car doing? Is it happy with you messing up with the charging system?
I haven't tried yet. I guess like right now it's very much like simulated environment, but there's a bunch of like open hardware out there for actually building a charging station. I'm not sure I will. Yeah, I will probably be doing it with like toy miniature cars for the demo. If
Yeah,
you
that
don't mind.
that's a good idea. This reminded me of something I did a few years ago when I was starting to play with Canvas, and I did a USB Canvas interface, and I decided that the best thing to do was to try it on my father's car because that was the only one I had with Canvas on. And I might have set the wrong bitrate and did not set the controller in listen only mode. So I remember turning the car on and getting errors everywhere. I wasn't exactly happy about it, but it recovered by itself after fixing it. Yeah, cars.
Ouch.
You probably want to use it for moving from A to B, not as a dev kit, unless you can expense one. And yeah, anyway, cool. All right, what else
Yes.
happened?
Yeah, well, so I guess we can go through some of those news that you mentioned. Some of them, as always, are like really like 100% Zephyr related. Some of them maybe more like random industry embedded news. I guess Zephyr wise, one thing that's nice to see more of, and that's also a reminder for folks who have like their own projects that might fall into that category. We have more and more so-called external Zephyr modules being contributed to the Zephyr documentation. Basically, like Zephyr ships with a lot of modules and subsystems that you can that are either already enabled or that you can optionally enable. But maybe more importantly, there you will find on GitHub and elsewhere lots of libraries and projects that are effectively have the required metadata to be easily pulled into a Zephyr workspace. And so we really encourage people to contribute those. Like you just mentioned, connectivity is one. There's a bunch of TinyML projects like EMLearn is there, Zeno, quite a few others. And this week, there's a few more that were contributed. The guys from Wolf SSL, they have a bunch of modules for Wolf SSL itself, but Wolf SSH as well, I think. And like, they're starting to line up the documentation for that, so you can find it on the Zephyr documentation now. Folks from Ant Micro, they have this project called Zephlin, which is a profiling library, which looks really quite cool. Like they have documentation that's pretty amazing, and I think it can also profile things like AI inference engines and so on. So it's, I mean, it's now documented how you would pull that into Zephyr. I think one that will be coming soon too. They just did a blog post. Is the folks from Edge Impulse. They now make it more easy to basically pull in the Edge Impulse stack for doing TinyML in a project because they now ship a Zephyr module. So I think it even like as part of their cloud-based like IDE. You can export ready-to-use projects, Zephyr projects that are properly set up with Edge Impulse being pulled as a module. So yeah, like in short, more stuff that's readily available for people to enable in their projects, and more excuses for people who have similar modules out there to please just send the pull requests to make sure that we have like a really good documentation and a good reference of what is out there, basically.
It's really cool to see more modules being available for the project. um, I, I think that at this point, yeah, the right thing to do is to build a database of modules that can be used and enabled. It's a shame that we don't have all of them maintained upstream all the time, but at this point, it's just too many. I think that for a while in the project, the idea was to just bring them in, have a maintainer, and have them part of CI and everything. But it's a good and bad thing with the growth of the project, I guess, that there's more and more available. So at this point, I guess the best thing we can do is list all of them and make sure that people can find them.
Yep. And also, I mean, not all of them might be like fully open source. Like they, whatever, if there's a company behind some of those modules slash projects, it might be sometimes, I don't know, like dual licensing or whatever. And at least in my, from my point of view, like that's fine. Like that's still like making it easy for people to discover that this exists. This is part of the Zephyr ecosystem at large. I think it's important.
Yeah, and this was this came from a discussion that happened on Discord about Wolf SSL, right? Because it's not, I think it's GPL v3. So the integration, if you're doing a product with one of these modules, obviously you as the application developer are responsible for making sure that the licensing is all right, right? But yeah, I mean, obviously there's situation where things can happen. Like I think Wolf SSL sells licenses, so take a license
Yeah.
from that one
It,
product.
it's probably fine for some people. Yep.
Yeah. So yeah, jump on Discord to discuss about licenses with people that are not lawyers.
That are not lawyers and have an opinion.
Everyone is like, I am not a lawyer, but this is
But
what I think. But yeah, another thing you can jump on Discord for is discussing the build times. Did you notice builds getting slower in the last few releases, Benjamin?
yes and no. I think the thing is that, I mean, Zephyr upstream, and we kind of covered that last week, in a sense. There's more and more drivers, more and more boards, more and more SOCs, and
Features.
I think part of the build system, at least as the way it is um, implemented today, I mean, the more boards, I mean, it has some overhead on the build time, and I think that was the gist of the discussion, right? That
Yeah.
if you build like from scratch, like with a clean build folder and so on, like the first build, it might take slightly more time than in previous releases because we basically have a couple hundred more boards that maybe the build system goes through to like create its own cache and
Yeah.
whatever, parse the schemas, etc. So
Yeah.
I think that was kind of the explanation mostly, right?
Yeah, if I understood, I didn't follow the whole chat. So this happened in Hash release. Alberto brought it up, and it's actually nice to see that somebody's thinking about this stuff. But yeah, apparently the build time for, I think this was the Hello World with the latest tool change, so just changing the Zephyr release. I think it almost doubled. It went from like 2 to 3.7 minutes, something like that. And yeah, I think most of the blame, or at least a big chunk of the blame, was on the Python script that generates some of the file, because I guess Python is not very efficient at importing thousands of files for the boards. I guess, right, for the YAML file and then do processing with it. So yeah, we'll see what's gonna happen.
Yeah, and I think, and unless I'm wrong, um, that sort of slowdown that was observed, it's really like it's an absolute number. It's not like relative. Yes, it takes like maybe a few hundred milliseconds more to build Hello World, but Hello World is like really minimal. it's the same overhead like for a big
Right.
application. It's not like it's
It's a,
20% slower, if you know what I mean. It's
yeah, it's
just like there is
a
this
fixed
small
cost.
overhead, the bootstrap or like however you want to call it of the build system, which still is an issue in a sense, but yeah,
Yeah,
we
yeah.
should track it better, I guess is the bottom line.
Yeah, it actually would be nice to have some long-term monitoring for this kind of thing. But yeah, you're right. Like this is a fixed time, and then if you have a big project, it's not going to happen. But yeah, it's interesting. Actually, I did notice it as well because when I did the Zephyr ration setup, one of the scope was to give something tangible to prove people that you can do a full checkout of Zephyr and a build in a very short time. And I remember that the whole thing used to take like 1.5 minutes, and then it started to take longer. And like I wasn't really sure what was like who was to blame. And yeah, initially I thought it was just GitHub, not us. But yeah, no, turns out that
Well, I mean, like I said, it's
more
for
complex.
the whole thing. Yeah, it also, I mean, the Git repo becoming larger and all the modules being pulled, like there's more data transfer that has to happen, etc. So yeah, it,
That's right.
yep. Before we started, actually, you were telling me that you've been. We usually ask each other, like, have you been working on some cool projects? You're usually the one working on cool hardware and so on. Have you been working on something this week? I might be biased because I know the answer. It's always yes, but
Yeah, I have a bit of a backlog of board that are being delivered these days, and this is all the stuff that I kept myself busy on my 20-hour flight a couple of weeks ago. Just yeah. Well, the only thing I had on the airplane was bad movies and KiCad. So one of the thing I did was another small light, and this is again using an STM32C0. And this week I did the power management stuff, which I don't know, maybe I'm biased, but for me, it's been historically something that always gave a few problems. Like it hasn't been so easy to set up in many embedded systems just to get it right. And this time it worked flawlessly. So yeah, I just wanted to mention that the ST folks did a good job. This is for supporting the wake up pins on most of the STM32. So as I mentioned, this is a C0. And yeah, basically you can put a flag in the device tree for your button, just saying like, hey, this pin is a wake up. And then you enable power off. You enable wake up pin, which is exactly what the sample does. There's a sample that does that. And then you call system power off, and it just works. And I think this is amazing. This is the good stuff that we have in the project. You set a couple of config, a couple of flags, one thing in the device tree, and you have your feature working. So yeah, good job. I've read zero documentation about it. I just checked the sample, copy pasted it on my project, and yeah, the thing shuts off, and the whole system takes like 7 microamp, which is still more than it should. But I'm not gonna start
yeah,
troubleshooting it
like if,
further.
when you're as long as you're in that order of magnitude, you're yeah, you're probably close enough. Yeah, that's interesting. That's I guess we need to talk more. Both of us, maybe offline or whatever, because I'm still going through the results of the developer survey. And as in previous years, I mean, so generally speaking, people are happy about Zephyr, but when we ask them explicitly, hey, if there were a few things, a few technical shortcomings that we should address, what are those? Power management seems to always come up. So I would be interested in like, yeah, figuring out whether it's a if the issue is that it's just some vendors need to catch up and implement more stuff that's available that just they just haven't enabled just yet in their drivers and SoC ports and so on, or if it's more documentation, but it looks like you just said that you didn't even have to read the documentations.
Yeah, well, this is it's a bit of a different thing though. What I was referring to was just the deep power state, like shut the whole system off and wake it up when a button is pressed or when an event happens. So that one, I think it's sorted out. But it's relatively simpler. while I think what the feedback referred to was the runtime power management, like the system power management, which is putting the CPU into lower state when the system is idle. Is basically something that tap into the scheduler, see when is the next event, and then goes into a lower power state with a number of constraints. That is a bit of a more complex thing, and the current design works, but I think could be better. And I had a few issues with that in the past. In fact, yeah, I have a long-standing issue called something like power management confusion or something like that.
Hmm. Yeah.
It's being worked on, but this is the hard thing, in my opinion, for embedded, right? Like this is the thing that I'd say you would put it on your resume if you know how to do it. Like, yeah, troubleshoot power management.
Yeah, and not everything can be done magically. Like that, the developer needs to also like put some effort into like
It's
explaining
it's a bit of an
what
art.
they want. Right?
Yeah.
Yeah.
And there's a lot of hardware crossover as well if you really want to be efficient, right? Like a pin with a pull up that is driven down when you're in low power is going to ruin everything. It's easier to have regression. And yeah, we could probably have a tech talk just on power management.
Well, just give me a date, and
No, no,
for
no.
you or someone else.
So someone else.
Yeah, well, yeah, we have a few folks in the community who certainly have it on their resume, or if they don't, they could.
Jordan Yates gave a good presentation at ZDS Prague, I
Yeah,
think. And
and we'll put the link in the notes. I send that link to many people when they want to learn more because it's really
yeah,
good indeed.
it's a really good one. It starts with test things and then it continues to start desoldering components.
Yeah, yeah. So yeah, so speaking of projects, last week, as part of the many sensors we were talking about, there was this leak detector from Microchip. And interestingly, and maybe this was already out as we were recording, but there is a really nice write up on hackster.io of a rain triggered greenhouse project. So, using a bunch of that sensor and a Microchip dev kit and a bunch of other things. That's quite nice.
The leak detector is back.
Yeah, pretty much.
I need to do a project with this. I want a leak detector in my life.
But yeah, it's good to see. And actually, like yeah, on Hackster, there's more and more Zephyr-based project these days. So we'll keep we will keep an eye on those, and we'll keep you all posted when there's cool projects like this one. What else? Hardware-wise, Open Risk. Did you want to talk about Open Risk? There's some.
Oh, this is cool.
It's been on and off for the past few months, but there's some interesting work being done in that area, right?
Yeah, this is very interesting. And I think that the thing that I found fascinating is that this actually originates from a product. And this is from some of the folks at NVIDIA, which I was not expecting. So apparently, they have open risk variant CPU in the monitors. They have a feature for gaming monitor called G-Sync, which I know absolutely nothing about. But my understanding is that this is something, this is a design that they sell to OEM like Asus, ROG stuff, things like that. And yeah, there's a CPU there. It's an open risk, and apparently it runs Zephyr. And so open risk, if you didn't know, is open source hardware architecture that came out many years ago, and it actually predates RISC-V. And it's it's a bit. My understanding was that it stayed a bit more in the academic space than RISC-V, who managed to escape and become a lot of product at this point. So it's probably not super important. And the person that is working on this stuff, I just can't remember the name, but he gave quite a bit of historical context as well in his presentation at the architecture working group this week. It was actually very interesting. And yeah, I think that there is still value in working on it, even though it's probably not something that you're gonna find in actual chip. Like it's probably not something that is gonna be taped out on your product. but it's still I think it's still being worked on. It's still available, and it's something that you can synthesize on an FPGA and use it for a FPGA plus custom core product. So yeah, this person is working on a port of Zephyr for OpenRisk, the core the version of the core that you can actually download and use. And yeah, he's doing a great job. I think that the work for integrating the SDK has been done. The pull request for the architecture is out. So yeah, looks like we're gonna have OpenRisk support on Upstream Zephyr, and there are products using it in the wild, which we didn't know about, and it's nice to know.
Yeah, that's really nice. Do you know off the top of your head, is there support in QEMU for it?
I think so. Not
Okay, cool.
100% sure, but I think so.
Yeah, that's great. So yeah, the PR is up there. Well, it might be one of the first pull requests we merge as soon as 4.4 merge window opens. We'll see.
Cool.
Cool. Yeah, maybe one last thing that I spotted, and actually spent some time trying even. It was really nice to see pop up on my LinkedIn feed earlier this week a post from the Raspberry Pi Foundation, where they basically announce they have a VS Code extension for Raspberry Pi Pico, which I didn't know existed, and I think was already a thing before this announcement. But the announcement is that they now support creating applications in Rust targeting the Pico or using Zephyr. And so I gave it a quick try. It's actually quite nice, similar to like how some other vendors do it. You have this extension that you just install and then you like click new project, hello world, blinky, whatever you pick your sort of like template, and then it does the thing. It does its magic behind the scenes, and you get to Blinky without having to worry about like literally anything, which I think is quite nice. I think some people would say, I mean, if you're doing Zephyr, you better learn it like the proper way, like follow the getting started, get your workspace properly lined up, etc. Which, yes, sure, but when you think about it, like many of us, at least I, and maybe not you, Fabio, but many of us in this industry is like, I mean, I started with Arduino, and I spent also quite some time with things like Platform IO, and I actually really like genuinely enjoyed the fact that I didn't have to think about the way things were happening behind the scenes. I really only cared about my actual application, and I only had to learn about what was behind the scenes when I really needed it, and when I needed to, I don't know, like do continuous integration or whatever, and I would need to know how things are effectively structured in my workspace. But otherwise, I really only care about main.c, right? For in some cases at least. So that's basically the approach they have, I think. And yeah, I quite like it.
I think that there is definitely value in that, right? And yeah, like for getting started, for learning stuff, there's probably different approaches that work in a different way on different people. But I think that for what Raspberry Pi is doing, the best thing is probably to make sure that people can get something moving quickly so that they get engaged and they realize that this is interesting, and then you have something where you can start and then dive deep on the various aspects of the whole thing, right? So no, I think that there's value in that. And do you think this is the first time that Zephyr gets officially acknowledged in, like, this is on raspberrypi.com/news or something, right? I mean, it's the first time that the Raspberry Pi project officially acknowledged that Zephyr exists and
Oh yeah,
support.
probably. Yeah, I think they have like a dedicated forum and stuff like that. But yeah, I mean, it's nice to see them making some noise about it, and I hope we will see more of that. So yeah, pretty cool.
Yeah, then this is definitely something that is going to drive more engagement and help people, yeah, working on project and using Zephyr on their chip, which I think is really cool because they have a pretty powerful chip, right? Like it's fast, it has a lot of flash, you can load a ton of feature, and yeah, especially if you have Zephyr, like with how the RP 2040 and the other one work, you can like one cool thing of those architecture is that, like many other modern one, they have external flash, so you like enable all of the shell commands. They're gonna eat a lot of flash space, and if you don't use them, who cares? You have like 2 MB or something like that. So I think it's a good fit for their platform. Yeah, it's good. It's good to see them using it.
Yeah, yeah, pretty excited about that one. And I guess moving on to bigger, like
Oh,
even more processing power and basically servers, we saw some really cool news from Alibaba and around OpenBMC. And so you've been having maybe a closer look than I have, and maybe you know even
yeah.
more about OpenBMC. But like, what is it, and like, what was those things we saw on? I think Quinn Wang from Alibaba showed up on Discord and shared a bunch of things in mailing lists, etc., about basically Alibaba Cloud starting to use Zephyr somewhere.
Yeah, I didn't know that this was happening. So this is a presentation that got posted on LinkedIn, I think. At least that is how I found it. Somebody pointed it on Ash Random on Discord, and it's a pretty short presentation. I think it's like 20 minutes or something, and this has been presented at the Open Firmware Summit. I can't remember. I should I should have written it down. So this is a conference mostly about higher level stuff that we work on. Like I know because some of my colleagues are going there, and they talk about the stuff like core boot, or they talk about ACPI, EAU, EFI, stuff like that. And yeah, so OpenBMC has a presence in the conference. So this is about board management controllers. And in case you didn't know, this is the stuff you would put on a server for doing out of band management, right? So we're talking about a chip that is put on a server next to the big application processors, and this chip stays on all the time. It's typically on a separate network, and it's used for remote server management. So taking the server, turning it on and off, accessing the serial console, sometimes accessing the VGA, and doing like IP-based KVM, things like that. I think that the biggest one can do remote reinstall, like expose the USB drive on the device, and yeah, it's stuff that you have on your standard rack server to avoid having to send a technician every time something goes wrong. So typically, this is done with some bigger CPU running Linux. So you need CPU, you need flash, you need DRAM. They take a bit of power. They take quite a bit of board space, and it's been done for a while. And actually, I think that Zephyr on board management controller is not exactly a new thing, because um, there are one of the big vendor for general purpose BMC is ASPID,
Hmm.
ASPID, and they already have Zephyr support for some of their chips. They had it for a while, but it was a smaller Cortex M microcontroller class of device, and I think it wasn't quite a full feature BMC. But then this came out recently, and the presentation was amazing. So the folks from Alibaba ported OpenBMC, which is a full blown board management controller stack, and it's based on Yocto. So it's normally something built on top of Linux, and it builds a bunch of processes, and then they run and start. So they basically took all of the modules, and they ported them to run on Zephyr using the POSIX API. And the presentation made it sound like it was very easy.
Yeah,
So
I'm so obviously this is a podcast. So, but I'm looking at the diagram, which people can check out when they're back from their commute or whatever. But like that diagram kind of makes it feel like whatever they had in the Linux-based OpenBMC, they just copy paste the whole thing, and like it just works. Like those diagrams are like mostly identical. All the features
yeah.
are there, right?
Yeah, I'm sure. I mean, I'm sure it wasn't as easy, right? But the way they sold it was like, integration effort was very low, code reuse was very high. It's like, okay. And they said like, oh, the learning curve for the existing developer for the new port was minimal, which is absolutely amazing. And I highly recommend watching the presentation. And this diagram is really cool. So like I'll try to describe it very quickly, but we're looking at two simplified, I presume, software stack. So you have your application, your framework, your kernel, and then the hardware. And you have the Linux based on one side and Zephyr based on the other side. So they have on the application layer, they have full compatibility. And then they have the framework and they have seamless integration. And then the kernel is replaced and that's it. So make it just work. Benjamin,
Yeah, well, I mean, go POSIX, right?
you're right.
The wall.
So there's only one thing on this diagram. Can you tell what's missing from the Zephyr base stack compared to the Linux one?
So I can spot one. Well, there might be two, but it's so it looks like for like they replaced GBus with ZBus,
Us? Yeah.
right? And got rid of or didn't need system G, I guess.
Yeah. So if you look at this diagram, it's like, hey, this is just like Linux without system D. I'm thinking this could be our next presentation. Like, hey, what is Zephyr? Oh, it's just like Linux without system D. Thank you. Can I have it?
Yeah, well, so but you were mentioning like demos before. Like, I would love to like. I mean, we need more of those. Like, basically showcasing how you can take like a big beast that's some POSIX based sort of like application or library and whatever, and just run it on Zephyr.
Yeah.
Should just
Yeah.
work. Most
Yes.
apparently, at least it
To
does in
some
their
extent.
case. So
Y- Yeah, as long as nobody decide to port system D and make it system Z or something. Anyway, really cool project. So yeah, the key of the presentation was that they did this chip and they say that it's the world first BMC chip, DDR less. So like, they didn't quite explicitly acknowledge it, but the intent is probably a cost reduction, both in terms of chip and BOM, like component count. So yeah, the traditional BMC for them is external DRAM run Linux. This one has SRAM, I imagine. Well, yeah, one of the things that I wasn't expecting was that this has SSH, and we're going back to the to what mentioned first. This run Wolf SSH. So
yeah,
yeah,
right. We don't have an SSH implementation in tree, do we?
no, because it probably needs all of the other crypto stuff, but Wolf
Yeah.
SSL is there and Wolf SSH clearly works. So they even show the demo of the shell command, and you can see the normal Zephyr shell, the one that you would get via UART, and they access it through Wolf SSH. But yeah, so really cool. Apparently, it was almost a drop-in replacement with ZBus, POSIX, Wolf SSH, all of this stuff. Very interesting.
That's really cool. Yeah, I feel like I want to build my own small data center just for the sake of playing with it. No, that's really really nice. And what was even nicer, as in like really exciting to see, is that like they reached out to us like Quinn and like the Alibaba guys are yeah, super happy about what they um, what their experience was. And I think the call to action, I guess, here in this podcast is, if you're listening to this and this is sort of a use case that's sort of close to what you're working on, there might be an opportunity for even more collaboration and more upstream work. So that's I think, yeah, that was worth a big shout out to them.
Great presentation. Thanks for
Yep.
sharing.
Well, I will. So full disclaimer, I didn't actually watch it, but you sort of convinced me, and it's only 20 minutes, you said, so I will check it out. And with that, maybe we can go quickly through some of the. There were a few PRs merged in Zephyr after we recorded last
Yeah.
week and right before the feature freeze. Hardware wise, there's yeah, I guess you want to talk like there's one board that got your eye. What is that? The
Yeah.
PSOC
Yeah, this got in at the
P84.
last second. The PSOC Edge E84 AI. My tech lead gave a presentation a couple of weeks ago, and he mentioned like, oh, we need to pay the AI tax, and he showed some AI generated image. So yeah, there we go, our AI tax for this episode. Yeah, so this is a PSOC board. Infineon for former Cypress. It's kind of cute. It's a tiny board with two USB-C, and yeah, it has a Helium DSP AI accelerator thing, whatever. But what I found interesting was that this has a Raspberry Pi compatible MIPI DSi display. So I think that's cool because there's a lot of interesting accessories for Raspberry Pi that use the display connector and the camera connector, and it'd be cool if we can see more system on chip board, MCU board that can use them. And this one can use the display, evidently. It also has a camera module port, but this time it uses a normal parallel type of chip. And Wi-Fi, Bluetooth, seems like an interesting board, worth mentioning it.
Cool. Well, yeah, one more board, more boards.
And more board and more driver, more sensors.
Right. Yeah. So there's one a tachometer GPIO based driver for, I guess, counting RPMs of like fans or like what is it?
Yeah, so general purpose tachometer driver. So you can have like a fan. I think it's not this uses GPIO interrupt, and it uses the system timer for the speed. So it's probably not fast enough for your car, but it's definitely fast enough for fans. And yeah, so this is a general purpose driver, and it exposes a sensor API giving a RPM reading. So there you go. If you need to measure faster thing, there is an example on how to do it using the timer or counter. Can't recall one of the two API. Connectivity has it, so that firmware uses a 1 megahertz dedicated clock just for timestamping. But if you need to measure something that is not that fast, this is a very good one. General purpose.
Yeah. Okay. Interesting. But yeah. So I was a bit. I mean, obviously, you know better than I do about like those sort of like driver stuff and so on. But I was kind of confused because I feel like I had been told in the past that those kind of things, basically turning some kind of interrupt happening on a GPIO at regular intervals, turning that into some frequency slash RPM readings. I thought that this could or should be something that developers would be doing at the application level because it's like
Yeah. It yeah,
it could.
it's always a conversation, right? Right. Yeah. Because yeah. Well, in this case, there is a definition for RPM in the sensor interface. So I think there's good value in this. But yeah, every time we see a driver that is using some general purpose thing to convert to another general purpose thing, it's worth asking the question: does this belong to upstream or belong to the application? But I think in this case, it's a good fit.
Yeah, that makes sense. Making the stuff like you enable a few things in your device tree, and then you automatically get a high-level sensor API to access the consolidated slash computed
Right.
RPM data. Yeah, that makes sense. Okay. Yeah, there's a new shell for the haptics subsystem. Worth calling it out. Like, I would need to have a look, but I'm pretty sure most of the device driver classes have some kind of shell support. Actually, I was thinking the OCPP stuff, the open charging
Point.
point thingy, it doesn't have a shell. It should have one. Uh, I will think about it. And what else? The ST guys, they worked on maybe not just ST, but there's a new video encoder thingy for when people build webcams and UVC USB devices.
Yeah, this supports H.264 and I think Motion JPEG, and the sample now supports it. So if you have a system on chip if you have a board that supports hardware video encoding, now you can use the sample to test it. Unfortunately, I think it's only the STM32N6, which only comes in a BGA, so it's not very hobbyist friendly. But I know you have one.
Yeah, well, I do. Actually, that makes me think that back to the very beginning of the episode, that charging station thingy demo that I want to put together. As part of the demo, I want to showcase the twister display harness thing where you use effectively a webcam connected to your laptop, looking at the display that you want to test. Maybe I built this webcam device with this new STM board. Maybe I'll try that. But yeah, a few more things I need to I run out for this demo. This is RC2 day. Please remember that you need to if you want to if you are testing and you took RC1 for a spin and you found some bugs, um, feel free to just open bugs or better send pull requests and clearly label them and mark them as a fix so that we see them, we consider them for merge. And something else, I should also have mentioned it at the beginning of the episode so that people get the memo, but I will insist next week as well. There is actually a new survey coming out. We just wrapped up the developer survey, but it turns out that next year is going to be pretty big for the Zephyr as it's turning 10 years old.
Happy
And
birthday.
one thing that, yeah, happy early birthday.
Happy early.
Um, it's been quite a journey, and that survey is basically meant. It's not necessarily a developer survey. It's more like if you've been using Zephyr in your organization, and you've seen it. I mean, you've adopted Zephyr maybe last month, last year, 10 years ago. You've seen things evolve. There's things that are still pain points. And so sharing basically feedback on how you are using Zephyr in your organization, and so that we have basically input to help us plan the next 10 years, basically. And again, this is not only technical stuff. Like it's really more sort of like general approach. So if you see some posts about a new Zephyr survey, it's not the same one than the developer survey that you maybe already took. And so if you have a few minutes to spare there, that would be really good. As always, links will be in the show notes. With that,
We're
this is
done.
it. This is a wrap. See you next week. Bye.
Bye.